verification used to be all about vectors. Remember? Yeah, we'd randomly generate a bunch of zeros and ones, put in a few carefully selected vectors that we made up ourselves, and call it a day. Or actually, we'd just call it a morning, because usually by afternoon, somebody would have found a problem our vectors didn't catch. So we'd throw down a few million more vectors on the pile, and then... Yeah, you remember too, huh? Let's change the subject. Now, of course, we're much more sophisticated, and our designs are too. We've got software, multiple systems communicating with each other, video, audio, way too complicated for vectors. What we need now are use cases, and with the help of Cadence, we promise to do better this time. Hi, I'm Amelia Dalton, host of Chalk Talk. Verification is both an art and a science. And today, my guest is Larry Melling from Cadence Design Systems. We're going to talk about Cadence's new gift to verification engineers, System Verifier. Okay, so not literally a gift, because they do charge money for it. But anyway, let's get rolling. Before we get started, remember to click that link. There you can download a free tech packet that includes a Perspec System Verifier, datasheet, white paper, and blog. Hi, Larry. Thank you so much for joining me today.
Hi, Amelia. Thanks for having me. I'm looking forward to it.
So when it comes to SOCs, a lot of us are running into limitations even with methodologies like UVM. So I understand that Cadence is announcing a new solution that deals with this system-level problem. Is that right?
You're absolutely correct. What we are introducing is a tool we call Perspec System Verifier. And the interesting thing about Perspec is it takes a different approach toward verification at the SOC level.
Okay.
What we're doing is we're really creating an environment to make it very easy for users to create a use case that the SOC needs to accomplish, in order to do its job.
Cool, okay.
The interesting thing about it is these use cases, because the SOCs are getting so complex, become very complex. So what it takes to write that kind of a use case and create a test case for it is a problem, and it takes a lot of time. And so what our customers are seeing with this is that they can actually do in days what was typically taking them weeks to do manually, if they could do it at all.
Right.
Kind of the bottom line of all that is, why do this? Well, it's really about higher SOC quality. You want to get an SOC that comes back and is first time successful when you get the silicon returned.
Right. Okay, so before we jump into Perspec, take me back a bit here. How did we get here?
Sure, that's a good question. If you look back over what's been happening in dynamic verification over the years, we started with everybody trying to write a directed kind of use case-based approach to say, oh, this is what my part is going to do, and this is how I want to test it.
Right.
Well, the problem was people were spending a lot of time doing that. They didn't really know how much they had tested. And then along came HVLs and the whole metric-driven approach.
Right.
And that really made a huge difference, that you could go in and now say, oh, wait a minute, here's what I'm going to test, here's the rules, and it would go off and do the constrained random approach, and all of a sudden you've got bugs showing up right and left. Management's getting real happy that, oh my gosh, we actually might get this thing working the first time. Right? So it became a very powerful positive feedback system of having these metrics and the tests that would go in and find the problems, uncover the issues.
Yeah.
So that was great and continues to be an absolute essential part of how people are developing SOCs.
Right.
But when you start putting the SOC together, it becomes a different issue, because now you've got hundreds of different pieces of IP, all this stuff coming together, and the space becomes so large that an exhaustive test isn't practical.
Right.
And that's why we keep referring to this whole use case thing, is the idea of creating a top-down level use case, but we don't want to go back to the old days of saying, oh, here's a directed test, and there's no metrics behind it or anything else. So we really want to apply what we've learned in metric-driven verification at the SOC level and say, let's create a top-down use case, but let's make it controlled from a metric basis. And let's think now about, now we have to constrain not only constrain random data production, but also the control flow.
Right.
Because we have to see things can happen in parallel, serial, you never know.
Okay, so as I'm leveling up, Larry, this universe is so big. I really have to determine what I care about verifying. Now, how does use case compare with what I'm used to dealing with, say, UVM?
The best way to get to the details about that and explain it is to really look at what a modern SoC is today.
Sure.
So as I mentioned, there's many IPs here. There's a bunch of standard I/O IP that just has to be there so that I can communicate.
Right.
There's a set of system infrastructure IP, the stuff that is the core components, the things that give me the interconnect coherency and the multiprocessor communications and all that kind of stuff. And then there's a whole set of key differentiators that I am developing myself for my device, whether it be my modem or my GPU or some other type of hardware accelerator. Those things have to be also in that system.
Right.
And each of them kind of have their own level of concern. So if I am NVIDIA doing GPUs, guess what? I really want to make sure my GPU is right.
Right.
The USB device that I bought from another guy, well, I want to make sure it works in my system, but I can kind of believe that that was tested.
Sure.
So I'm not going to spend a lot of time creating a system level use case to exhaustively exercise USB.
Yeah.
But at the system level, I do want to look at how is my GPU going to be operated throughout that process.
Right.
Now, the interesting thing that that brings out is that not only are these IPs, but also a lot of these IPs now contain cores.
Right.
So you have an actual execution engine, processor there that is running software that can be utilized in that verification process. Then the final piece of that puzzle is that software. So today, we don't have the situation where it's just about building a hardware chip.
Right.
People are producing hardware and software, and in fact, chips don't really work without some basic software.
Yeah.
There has to be some stuff there that gets them initialized, gets them booted.
Yep.
And more and more we're seeing that the producers of the SoC are taking on more of the software problem.
Sure.
And so that's a key element that any solution that we come up with has to really consider the fact that there's software functionality that has to be verified and hardware functionality that has to be verified.
Right. All right, Larry, people have been producing SoCs for a while now. What exactly is the problem again?
That's a really good point, right? That we've got all these mobile phones out there. These are complex SoCs. They're working.
Yeah.
Everything's great, right? Well, I think that that's absolutely true, but there is a set of gaps that people have found in doing that and issues. And those issues, as the complexity of the SoC increases, become more likely to bite you in the end.
Sure.
Right? And so what we've seen with people that are producing these SoCs is they approach that complex hardware software problem and they do a couple of things. One, they say, okay, well, I can write some basic software tests to make sure that I can run software and activate different components, and I can have different components talking to each other and set all that up.
Yeah.
And I can do a decent job at that, but it's pretty basic. I'm not going to get into anything too complex of saying, oh, well, what if I have these processors being coherent, and then all of a sudden I want to power down a couple of them or something, right?
Yeah.
So they do that approach, and then when they get to those more complex use cases, they kind of say, well, that's going to take too much time to write the test. I'm going to just use my production software stack. I'm going to boot Android. I'm going to run some stuff on top of it and see what happens.
Yeah.
And that's really where the challenges come, because now you're doing directed test without measurement. So we're going back to the old days of doing directed tests without measurement.
Right.
And that's not where we want to head. We want, and our management wants, some sort of proof that we've verified this thing and it's going to do what we want it to do when it comes back from the fab.
Right.
And so issues of how do I measure this? How do I write a complex test that is measurable?
Yeah.
Those sorts of things of what we're trying to address with Perspec.
Okay, so how do we approach solving this? It seems like we have both technological issues and people or team challenges here as well.
That's exactly right. I think if we take these problems that we talked about and level it up to say, well, what are the core requirements that we're really looking at here?
Yeah.
Okay. There's really kind of three axes that we look at. And they're sitting there saying, well, first, there is the use case problem. How am I going to capture these complex use cases? And not only that, how can I take a complex use case and allow somebody like an architect to say, oh, well, this is how coherency works. This is use cases that are going to exercise coherency, and pass that on to the system verification team to say, if you're going to test coherency and power, use these coherency use cases.
Right.
Right?
Yeah.
And so the reuse of those use cases between the ability to capture them, quickly and effectively, and the ability to reuse them is critical.
Yeah.
The second piece is, as I create a use case, I want to be able to use it at the low level, the IP level, and also as I go up. So as I add the IP into a subsystem, use it there. As I add the subsystem into the SoC, use it there.
Right.
So we really want to have that capability to what we call vertical reuse, from the IP to the system level. And then finally, to do these SoCs, everybody is applying multiple platforms. You got virtual platforms for early software development.
Yep.
You've got obviously post-silicon platforms for doing a lot of the final power and performance tuning and different things like that. And then there's the simulation, emulation, acceleration, FPGA platforms that are used throughout that process to really give people the platforms that they need to get their development work done.
Gotcha.
Well, whenever you're doing verification, obviously, you want to take advantage of those platforms. So the idea of being able to take a test case that I've run on the virtual platform for early software development and reuse it when I get onto an FPGA platform doing further software development makes perfect sense.
Yeah.
Right? We don't want to recreate the test.
Absolutely.
So those are kind of the three areas.
Okay, so those requirements do make a lot of sense, and I think I have a handle on those, but we're here to talk about Perspec, so let's dig into that.
All right. So Perspec takes those three requirements and it takes a step back from them and says, okay, well, obviously we have to start at the use case. How can we make it easy to create use cases?
Okay.
Well, first of all, we have to make it easy to create use cases, but to also share them.
Sure.
Well, what language can I talk in?
Yeah, good point.
If I talk to a verification person, they're going to want to talk system Verilog. If
Yeah.
I talk to an architect, they want to talk C++. Software guys want to talk C. So everybody has their different view of the world.
Right.
And so what we have to do is we have to create an environment that says, well, what's in common here? And so what we did was we said, well, let's create an abstract model that says really systems are about actions and resources. So all I need to do is be able to tell, oh, this is the action that the system is capable of doing, and these are the resources that it's going to need to accomplish that, and this is what it's going to produce.
Right.
So if I can give that declaration and express that in a way that people can easily visualize and see it, then I'm a long way toward the end.
Right.
Now, the issue is I want to do it at an abstract level, so if I leave it there, I don't have a test.
Yeah.
So now I got to worry about, well, how do I solve this thing? So I've got this abstract picture. How do I make it into something that's going to be a test? And so that's why we have taken the concept of constraint solving to the next level.
Okay.
And what I mean by that is constraint solving was typically a data randomization approach to being able to get coverage. Well, in the system world, you not only have to deal with the data, but you also have to deal with the control flow.
Sure.
So the solver has to become more sophisticated to be able to do randomization on that as well. And then finally, once you have something that you could write a test case for, why not automate it?
Yeah, right.
Let the tool do the work.
Yeah.
Have it generate the C code for you. And it's exactly what Perspec does. We start with a composer that lets you capture the use case. Then we move into a solver engine that lets you fill that out into a concrete solution. And then that concrete solution, we can generate C code to test.
Cool. Okay.
Then that C code, obviously, you load that onto your device, and that device model can be a virtual model, it can be an emulation model, an FPGA, or an actual silicon platform.
Gotcha. Okay. I'm starting to think that use cases might have something to do with all of this. Call me crazy. I don't know.
Listen, I guess I have been a bit repetitive, but, but it actually is really, I think, the key behind all this.
Yeah.
And the reason is, as we said in the front end, we're saying, well, an SoC, if you're going to try to exhaustively test it, it's just not going to happen. There's just so many different spaces and
Right.
options available to you. You really have to come back to that use case.
Yeah.
And we put this together to kind of show you a little bit more about what is a use case.
Yeah.
So I can take something and say, well, I'm developing an SoC for the mobile market. And I get requirements from my customers that say, well, my customer wants to be able to view a video while they upload it to the web.
Okay.
Okay, that's a nice, simple use case. You think, all right, that's easy. So now you get into your SOC, and now you have all these options.
Right.
Right? Oh, okay. So one thing I know is the use case requires that I be able to display and transmit it at the same time.
Yeah.
So I capture that and I say, all right, so I want to display and capture at the same time. So I put that down and say, those two actions have to happen. They need to be connected and they need to occur in parallel.
Right.
Done. Well, then it says, well, you need input for that. So to get input for that, I need a memory buffer that has a video in it. And then before you know it, it's the give a mouse a cookie problem.
Right.
Now you have data in the memory. Well, how the data get into the memory?
Yeah.
Okay. Oh, I need that data in the memory, and I need it in a certain format. It had to be converted, et cetera, et cetera, et cetera. So you get the idea that the whole thing kind of snowballs into, oh, I need this, then I need that, then I need this, then I need that.
Right.
And so that is the world of the use case and why they're not only so important, but how they become complex quickly.
Sure. I think I've got an abstract view, but what about the real deal? What about a real use case here?
Exactly. That is one of the critical elements. We have to keep it abstract so that people can manage the complexity and be able to create the concept of a complex test. But now I need to use my computer
Right.
to take care of the next part. And so that's where the solver comes in.
Ah, okay.
So that's where we take that abstract use case and run the solver, and the solver will generate many different solutions to that use case. And it will identify solutions that are legal versus illegal based upon your constraints. So it does that, and now each one of those concrete solutions can actually become a test case.
Right.
And so you'll see that it goes through and it'll say, oh, well, to get that video data, I have a lot of options. In this case, I'm going to select to get the video data from the camera. It's going to produce that, and then I'm going to get it all decoded, and now I'm going to display it on this particular display because it can handle that particular resolution. So it goes through and figures out what information you've passed it, knows what it can legally do and what options it has, and creates those solutions. And now I can push a button and generate that C test case that fulfills all that, and you can actually run on a platform, and while it's generating that test, it says, oh, this should give you this coverage on this particular solution. So the whole solution space are all these different solutions, and each one of them produces some amount of coverage for that whole solution space.
Right.
And so it calculates that as part of the solver, and then when you run the test case, it'll say, okay, you've run this test case, and the information that I got back from the test case says, yes, in fact, you did cover that part of the problem.
Right.
So then you end up with a regression suite that basically all these different tests to cover that whole solution space.
Okay, so this all sounds great, but how do I actually do it? I mean, really, what is required to make this work?
Yeah, as everyone says, the devil's always in the details.
Right.
If you go into this, really the Perspec is, again, taking that general concept of putting together a set of user goals. So, I have a desired scenario that is, oh, I want to decode video from the DDR as shown in this picture.
Yeah.
And show it on a display. So I'm not even dealing with the transmit at this point. I'm just saying this is my scenario. And now I can push a button inside of SVR, and it will basically say, oh, okay, well, here's all your options. Here are all those solution spaces. So what I do is I describe my scenario at that abstract level, and then we do the solution like we were talking about, and it gives me all these different options. Okay. With those options, then I can go in and generate C-tests for the concrete solutions that I choose, or all of them if I want. And what it does in that process is really driven by coverage. So what it's trying to do is say, I want to give you a set of tests that are going to give you full coverage on that set of user goals that you described.
Right.
So that's kind of at the abstract level of how you work with the tool. So if we get in a little bit more concrete, I think is probably what you're looking for.
Yeah.
The next thing is really the flow as to what I do.
Sure.
So the flow is, I start with this modeling language we call system level notation. Again, I kind of mentioned it's actions, resources, and it's a declarative language. So it's meant to be descriptive in terms of what the actions are and how they're constrained, but it's not a big job of implementation. It's not like, oh, I have to figure out how USB works and what the protocols are or anything like that. It's a high level description. So I capture that, And then once I have those elements, those are the elements that I draw in to create that use case.
Okay.
So I do that. Then, as I said, you go into the composer, you visualize what the goals that you want to achieve, generate those maps, and then generate the C-tests that can be run on any of the platforms.
Gotcha.
Now, when you run them, the other side of this is tests cause failures.
Sure.
And you have to debug them, right?
Yeah.
And so debug, again, when you're talking about a complex use case, how are you going to track that problem?
Right.
Well, yeah, I can give you the C code and let you debug at the source level, and people do that, and you have to get down to that level at certain points. But it's much faster if I can give you that same UML-style activity diagram that says, oh, here's where I am in the activity diagram, and
right.
oh, guess what? Here's where I went awry. Now I dive in and start looking at the code that was generated and figure out, was it a hardware problem? Was there something wrong in my software? Which side did the problem occur?
Yeah.
And be able to turn that around and fix it. And then the last piece of that puzzle is really the coverage level analysis. So you get all those coverage statistics, and then you can not only go in and do analysis on, well, what's left that's open that I still need to cover, as well as to be able to consolidate that system level coverage with all the old IP level coverage and things that have already been done. And now you give a complete report to your management of how well this has been tested and what's been covered.
Right. All right, so let's take it back a second, Larry. And didn't we talk about how these different users were wanting to share different information, and how does that fit into all of this?
I'm glad we're coming back to that, because that is really the key behind this. And this is why use cases are important, because if I can describe a use case, it's fine, but if I can't share that use case, it really limits the amount of complexity that I can add in my use cases.
Sure.
One of the classic examples of this is in today's SOCs, there are people that are domain experts.
Yeah.
Coherency is one of those, for example. You have people in your organization that live and breathe coherency.
Yeah.
And they are the right people to write the test case.
Absolutely, yeah.
And the use case to say, oh, this is how, not only this is how coherency works, but this is how coherency should be validated in other contexts.
Right, yeah.
And so that's really the key there. So you have that person capture their coherency use case, and then you have a person that's a power expert, okay, and they're capturing their power expertise and saying, okay, well, you want to make sure your IP works in our power system. Well, here are some power use cases that are going to put you through your paces, right? Really stress you in terms of, is your IP going to work? Is this thing going to work in the system under power management?
Right.
And so I can hand that off. And again, because I'm using this UML activity diagram or UML view, it becomes pretty easy for an engineer to look at this and say, oh, okay, I see what's going on. I don't need to understand how I actually caused, a cache line evacuate, right?
Right.
or how I powered down the processor, but I can see that that is an action that is being accomplished here, and I can combine those things and bring them together and say, oh, now here I'm going to run 3 processors sharing a coherent cache, and they're going to be operating on that cache. Now I'm going to go off and I'm going to power down 2 of those processors. That one processor that's left is going to continue doing cache transactions. Now the other 2 processors power back up, and now lo and behold, they want to start doing cache transactions. So again, you're full circle. You get all 3 of them operating and doing those cache transactions, and you're able to assemble that kind of a complex test in a very short period of time, because you're leveraging standing on the shoulders of others, as they say. Right.
All right, Larry, this is a lot to take in today. Let's recap your main points.
Great. So just to kind of come back around, I think at the top level, hopefully the message that was sent is abstraction is key. I need to be able to capture these things at a level to create complex use cases without having to write the complex use case. So abstraction is a key element there. Automation is the next part of it. If I just have an abstract use case, I can't run it. So I need to automate that process. So you need the solvers, you need the ability to generate the actual C code to run.
Right.
Well, they're complex tests. The tests get bigger. To get more coverage, I'm going to have to run longer. Platforms become key. So you get down to being able to utilize the platforms you have available. So as FPGA platforms come online, I want to run those tests.
Yeah.
Run more testing on those platforms. And then, as I said, we don't want to go back to the unmeasured, directed test case kind of approach. We want to use a use case approach but measure it.
Right.
The whole calculation of coverage and understanding coverage. And as you'll see as you get into the use of the tool, it takes coverage to a new level because it's not only functional coverage, we're talking about temporal coverage. We have to look at performance, power. All these things are requirements and use cases that we have to meet.
Right.
And so you have to be able to understand, have I tested those and have I covered those and hit my power envelope, hit my performance goals. And then finally, that leverage, the ability to take from domain expert to domain expert and combine those domain expertise efficiently with yet another developer, and for them to be able to create more complex use cases from that system level perspective.
Well, I think that's all I have time for today. Thank you so much for joining me, Larry. This was super cool.
My pleasure. I really enjoyed it too.
Before we go, don't forget to click that link. There you can download a free tech packet that includes a white paper, datasheet, and blog all about Perspec System Verifier. For Chalk Talks, I'm Amelia Dalton. For more Chalk Talks, check out the EE Journal YouTube channel or the on-demand section of eejournal.com.